Okay. If you're watching this video on demand, which is a fancy word, kind of like an old word for watching the live stream after it happened, how dare you miss it? But also, skip a few minutes ahead because it takes me a few minutes to set up and make sure the audio's fine, and I need like a few people to join before I do that. So just like skip ahead. And I swear it will be good. It will be worth it. Now, at the moment, so do that. At the moment, it seems like there is one concurrent viewer. Okay, that means whoever's watching, it's you. You're the person. What I need you to do is tell me, do you hear me? Do you see me? Because I can't start until that is the case. Okay? Everything working, you hear me, you see me, and once that happens, I will begin. And until then, I will be still, like a flower, which will be topical for today. It's Cranciere, but your mission was to tell me. Okay, good. So everybody can hear me, everybody can see me. So here is what is up. So first point of confusion. It's November 3rd, yet I'm doing day 4. What's happening? I like to stay a day ahead so that I can not, mess up this Nodevember. I've never finished a Nodevember. So this is going to be the one. And we're going to host Thanksgiving, and there's going to be in-laws for a few days. No way I'm live streaming during that. So at some point, I'll probably get like 3 days ahead or something like that. With that being said, the prompt for day 4 is Bouquet. And for every day so far, I feel like I've taken it up a notch, okay? So everybody's making a pumpkin. I make a pumpkin carriage that actually moves the way it's supposed to, depending on varying ground. Fire. Most people are just making like a low-res fire. I roast a marshmallow in a physically accurate way. Ice. This is what we did yesterday. I used the physics branch to have physics while staying procedural to stack ice like sheets in Duluth. So if you're in yesterday's stream, you might remember that I was stuck on sample 2. Turns out it just takes a while. So this is what I ended up with. It's a single frame because it took forever to render. So I had those nice ice sheets. And I feel like that took it up a notch, this non-collision. So what do we do for day 4 for Bouquet? How do we not just make a boring bouquet? Well, here is the idea. You're going to see a few photos in my desktop of sunflowers, including a sunflower bouquet. So I'm going to probably make a bouquet of sunflowers. I'm definitely going to make a sunflower. And the question is why? Why is this more interesting? Well, if you look at the seeds, you zoom in here, you might notice this certain shape. And this is going to be more obvious here. You're going to notice this certain shape. You know that meme where somebody will take an image and then overlay that Fibonacci spiral on top of it? Like, oh, the perfect ratio. This is a case where this actually shows up in nature. So these spirals are the Fibonacci spirals. And the question is, why are the seeds organized that way? Well, it turns out this is the most efficient way to pack objects inside of a space, assuming that there's no collisions and they have to be like separate from each other. This is the most efficient way to do it. And you might ask, how does nature know to do this, right? Like, it could have made seeds in any way. And like, okay, the Fibonacci thing's good, but so it evolved to basically be like, whatever makes the most seeds is going to have the most offspring. So it's going to, So over time, I imagine that evolution converged on this solution. And more interestingly, the way that it does this is there's actually a algorithm. That algorithm is it makes a seed in the middle. It will then make another seed, which will push the other one out of the way. It will then make another seed that will push them out of the way. And you can think of this as an emitter in the middle. And then everything collides and moves outwards. And naturally, allegedly, we'll find out, it will inevitably form this shape. And it ends up being this because if you think of each seed as pushing the others, it's almost like an addition, which is how you get the Fibonacci sequence. So either way, the main interest is going to be these seeds, and then we're going to make some sunflowers around it, and hopefully we can make it look good. That is the plan for today. That's how we're going to take it up a notch. And if I can't get those Fibonacci spirals, I'm just going to fake it. So that's fine too. Okay, let's get cooking, people. And before we start, you're going to hear a lot about this, but I'm probably going to use a few free nodes, and those can be found at cgmatter.com. So you just type in cgmatter.com, you go to free nodes, and you don't even need to be a member. Although, if you are a member, you go to the Nodevember section, and so far I've uploaded everything. I'm usually a day behind, but that's fine. So, for day 4, we start by saving day 4. So we'll call this Nodevember day 4. How do you spell bouquet? It's not what I expect. Bouquet. Okay. We're saved. We're good to go. So how am I going to do this? Well, like I said, we have an emitter, and that emitter pushes things. So we're definitely going to need a simulation zone. And on top of that, we're going to need a collision system, which is actually super easy to do. We'll talk about it. So for reference, I think we should probably start off with this one. This shows the seeds the best. Let's start off by making a emitter. And I'm going to make sure snapping's on. Great. So how to do that? Well, I'm going to start off with a simulation zone. And every single frame, it will add either a point or multiple points. I think it should add one at a time, technically. So let's say we have a point. And that's just going to be 1 point starting at the middle. And I'm going to join it with all the previous points. So each iteration, it gains a point. So when I play this, you're going to see like nothing happens. There is a point. Why is that the case? Of course, because they are there. What does that mean? That means if I go into my spreadsheet, you can see every frame there's more points. They're just perfectly overlapping. And to make sure that they can shove each other, I'm just going to start off with a bit of variation. Okay, I don't want them perfectly overlapping, but nearly. So I'm going to start off with a random value for the position, which if we vary it on every single frame, so now we're still going to have the same issue. But if I vary it on every single frame, you're going to see what happens is we're now populating, okay? And specifically, I want to populate this such that they're kind of at the center right here, right? So maybe it can go as low as minus 0.1 and as high as 0.1. So now we have this clustering, and we might scale that. We might. So actually, let's do minus 1 to 1. And the idea here is then I can make a scaling factor outside of this. We can call it, vector math, multiply, and that's going to be by a certain number. Now, you're going to notice that I've actually isolated, or rather, well, now I've done this such that I've isolated the XY component. I don't want a Z component. I want a two-dimensional simulation. Okay? That just makes it easy, and it is so hot here. Let me turn down. I have this, remote to turn down the windows. And as I do that, I will talk about the plan. Okay. So if I spawn these, I wonder if you can hear that. Probably not. I have a pretty good sound isolating microphone. Okay, let's do that window. Okay, we're good to go. And I might change into a t-shirt in a bit. But if I scale this by a tiny number like 0.05, we now have something like that, and we just need to push them out of the way. Additionally, I want their radius to be smaller, not just so that it's more visible, but it actually depends. It affects the collision. So if I have two particles that are colliding here, of course they'll move out of the way. However, if they're very tiny particles in the same position, it doesn't register as a collision, right? So if I am varying the position of spawning by this much, maybe the radius should be the same number. You could argue that. Or maybe, assuming that most likely they will overlap, we can even divide by 2 so that it's more visible. There's an argument for that. But I think let's turn it off for now so we have a guaranteed collision. So we have that, and now the question is, how do we have them collide? Well, if you've seen my videos, you already know. We're going to have 2 particles. They are colliding. To resolve the collision, we're going to look at this overlap. So this is what we need to get rid of, this overlap. We're going to divide it by 2. So now this has a certain distance. I'm going to call it x. And each one is going to move in the opposite direction, like away from each other, by how much? By a distance of x. That way, they're each doing half the work. Or you can do it so that one of them does all the work, but then you have to say which one is the one that's allowed to move. So I think it's easier to do it that way. And we do this for every single point, and we're only going to collide with its nearest neighbor. Right? Because we want to find which one is the biggest defender, and that's going to be the one that's closest. So, nearest neighbor. This is a CG Matter node. Go to cgmatter.com to get it for free, or become a member. During the last live stream, there were 5 of you that became members. Okay. Great. So now that we have this node, what it basically does is it takes the, index of nearest and gives me some useful things. It tells me what is the distance to the nearest, what is the direction towards the nearest, and what is that normalized direction. This is great because now I can set position. Set position is going to let me move them, right? And I'm going to move them if the distance is a collision. So we talked about how to resolve a collision, but how do we detect a collision? It's colliding if I'm going to look at 2 points that are going to have, get your mind out of the gutter, that have the same radius. So in this case, you can see they're overlapping, and that's because their radii, when you add them, is bigger than the distance between them. So we have this kind of distance between them. And the 2 radii, when you add them, are bigger than that distance, and that's only possible if they overlap, right? Whereas if I did 2 over here, this is their radius, and this is their distance, you can see the sum of their radii is smaller than the diameter. So all we need to do is we need to take the radius, which is the same for all of these, making that super simple. I'm going to multiply by 2. And I'm going to check, is this less than, the thing. So I'm going to take the distance. I'm going to, what am I going to do? I'm going to take 2 times the radius and subtract the distance. And if that number is positive, in other words, greater than 0, that must mean that twice the radius is bigger than the distance. Otherwise, that wouldn't work, right? So for these, I'm going to move them, and we'll figure out how to move them. But let's do something like that. So I think that makes sense. We'll figure it out in a moment. So again, if 2 times the radius is bigger than the distance, then move it. Okay. And then the question is, how do we move it? We move it, again, if we have a collision, we look at their positions, and each one moves opposite to its nearest neighbor. Okay? So this is where that direction normalized is quite useful, because it will tell me what is the direction to its nearest neighbor, and it will have a length of 1. What does that mean? That means that I can scale this by, here's the difference, and remember that difference. So I have radius, and the distance. That, 2 times the radius being bigger tells you what is this gap, right? Because you take 2 times the radius, you subtract the distance, that is the overlap, and each one goes halfway. So all we do is we divide by 2, but only for the motion. And additionally, we're probably going to multiply this by -1, but let's just see what we have so far. Kind of hard to tell, but I do believe they're growing apart. And what we can do to visualize this is I'm going to bring down the radius, but after the fact, so it doesn't actually manipulate the simulation, just more so a post-processing effect. So let's see what this does and if it works. So clearly they're moving apart, but I think we have this issue where everything is moving, even if there isn't a collision, I believe. We will verify this. So let's see. We have something like that. This point right here definitely is not colliding, but it is moving, which tells me that we have the selection wrong or inverted. You could have just used the greater than instead of subtraction. Good point. Good point. Although, so somebody's saying, why do I need to subtract and check is that greater than 0? I don't. I could see is one bigger than the other. However, we do need the subtraction to calculate the motion. So we may as well, is I guess what I'm thinking. So let's do negative, and what does that give us? Okay, so that's definitely closer. And remember, some of these, like this one, that's looking like it shouldn't collide, we put this post-processing effect. Remember, this is in play. And you can see that's starting to make these spirals, I believe. We'll need to think about this, but I think this is either correct or very nearly correct. Okay, so let's think about this. So the direction normalized, let's just make sure it is what I think it is. It is the direction from the nearest point to itself, which points to the nearest neighbor. We normalize it, so of course I want to invert that. And then the length is the distance between them. Great. So I take 2 times the radius. I subtract the distance. If that is greater than 0, under that condition, then offset it. I think that's good, unless somebody has a different opinion. Oh, by the way, my Hebrew's not good, but I think it says Raphael. I feel like I've seen you on the channel for a long time. I recognize the Hebrew and the profile photo. So thanks for being our real one, boy. Can you, although Raphael's unisex, it could go either way, but I assume boy. Because if you look at my statistics, I know, okay? So there you go. And then I guess the question is, if we let this play for a long time, does it naturally make those spirals? It should, in theory. So let's see. It's kind of hard to tell because, like, the radius gets bigger, which may be something we should implement, because as the seed moves, the seed starts off tiny, and then as it gets more and more nutrients, it gets bigger and bigger and bigger, which might tell me that we should change the radius over time. However, now it gets a bit more complicated because we need to evaluate the sum of their radii, which is no longer the same. You can have a tiny particle. You can have a big particle. They're still overlapping, but the radius is different. So, I mean, if we're trying to go for biological growth, I think we need that. So let's do it. So inside of this node, again, at cgmatter.com, link in the description, we have the index of nearest. I'm evaluating its position, although I could evaluate anything. For example, I can evaluate its radius, and I'm going to output that. This is useful, and I'm going to name that. Yeah, somebody just said they need to be smaller in the center. I agree. Which is why they're going to grow over time. So I'm going to output the radius, and now instead of multiplying the radius by 2, it's a tiny adjustment. It's a tiny adjustment, but because I'm assuming they're no longer the same necessarily, I'm going to add these. Now by default, not going to change anything. Why is that the case? It's not going to change anything, and I need to get rid of this annotation. It's not going to change anything because they are all the same radius. Even though I'm adding them, that only matters if they are different. So the question is, how should they grow? Well, what we can do is for every iteration, I can move them, or maybe they should grow and then they move. They move and then they grow. It might not matter, but we can try both. So I'm going to set point radius, and the question is, how do they grow? Do they grow linearly? Do they grow logarithmically? Let's see. So we have a tiny seed here, and it gets bigger, and it kind of looks linear. If somebody can figure out why, I think it should be linear, because I don't think the seed grows faster as it's bigger. I assume it gets a constant stream of nutrients. So maybe what we do is I take the radius and I add some fixed amount, which should be dependent on delta time. So let's see what that looks like. Hey, hey, hey. It's working. So I'm going to take this delta time, which you can think of it's like resource allocation, and I'm going to multiply it by a tiny number. So it's still linear, but less. And maybe now we should get those spirals. Let's check. So it's kind of hard to tell. This is kind of, again, it's like that meme I was talking about. I think there are spirals. Like, it seems like they're kind of staggered in a way that looks familiar. And we can check that by adding more seeds so they're more cramped. But again, the seeds don't grow that fast, so it's all about finding that number. Yeah, Fibonacci. That's exactly what it is, literally, because of the nature of the process. I am funny, funny, funny. Okay. And now, interestingly, if I get rid of this post-processing effect, you can see they're about as perfectly spaced out as they could be. I guess one thing to note is that this is just a visual. It should be a sphere. It should be a sphere, which will render, but just so we can see it, I'm going to instance on points, a sphere, and for it to inherit the size of the point, its scale should be the radius. And now they look more like, you know, they're doing what they're supposed to. And maybe this will make finding those spirals easier. Can we make them less flickery? Yes. The way you would make them less flickery is there's two approaches. One is right now it's finding its nearest neighbor, which is the most important collision, and it's resolving it. However, there could be two pretty near neighbors. Even if one's the closest, there could be one that's fairly close. So it would kind of take a ratio between them to find the direction of least collision. And by the way, here, I think you can see it, because now we can see this growth over time. I do see more so those spirals. So that's one way. And another way is to just take substeps. So make it a smaller substep. So I wonder, if I divide instead of -2, -3, which again doesn't resolve the collision because now it's not each going halfway, they're each going a quarter, but they're still going to collide, that might be more stable. So this is this one, and this is -2. Another approach is what we could do is instead of adding 1 point every frame where it doesn't have time to breathe, I could do it either every 5th frame or a random frame. So like, for example, I take the count, I look at the frame number, and I take a modulo. And I'll explain this in a second. I'm going to run the integer math. I'm going to take it modulo 5, and I'm going to ask, where is this equal to 0? So what does this mean? This is the frame number. It's going to be 1, 2, 3, 5. I'm kidding. This is Fibonacci. But it's going to be 1, 2, 3, 4, etc. I'm going to take it modulo 5, which means kind of like a clock. It will always map to 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. And I check, is it equal to 0, which will happen 20% of the time. And in that case, make a count of 1, otherwise 0. So what we expect to see is this. So every 5th frame, And now they have more time to expand. So this is probably the simplest way to resolve collisions. However, now we also need to do that thing where they only grow every 5th frame. So I think this is probably the way to go. Thank you. I was not sharing the screen. So all I did here is I took the frame number and I took it modulo 5. So again, it goes 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. It checks where is it equal to 0, and then it expands it. And the only other thing I did is I played with this -2 value. It could be -4 instead. So this is what the more stable growth looks like. Versus if I did it modulo 1, would that be every frame? Yes. So you can see it's more stable. However, again, we do run into the issue. Where now they grow too fast. So we could just like, make this a tinier contribution. Did I just make that bigger? We take the delta time, I multiply it by a tinier number. Yeah, so now they should grow a bit slower. And let's just kind of see what this begets. What it bagets. Okay, I'm seeing some spirals. I don't know if I'm imagining them, but I feel the spiral. 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Now, you might be wondering, okay, so this process is vaguely circular. So here's another spiral. But how do we tell it to stop? Well, one way is we can make a collision ring that will also collide and it will want to stay inside. However, I have a more elegant solution. So I'm just going to let this grow. Okay. And once it's done that, I can just cull. So I can delete points based on their distance from the center, which is the same thing because this is a 2-dimensional, or even if it was 3-dimensional, I would take the length of the position, how far is it away from the origin, and I check is it greater than a certain number. If so, delete it. Okay, and that will let me cull this until it's roughly a circle. However, if you look here, I would say there's, what do you think, boys? 300 seeds? Something like that. So we need to let this run for longer. Let's clean up. So we have our nearest vertex. We add the radius. By the way, why am I using 4.5? What atrocity am I committing? 5.0 will calculate exactly the same. However, the nodes look nicer. Okay, so same thing. The reason I like this more is now, first of all, look at the node group. It looks much cooler. But if I hide this, it's a nice square, which I enjoy. So I'm going to add the radius. I'm going to run a subtraction. I check, is it greater than 0? Anything that doesn't matter and won't change, I'll keep exposed. I think -2 I'll also keep because I want it to be physically accurate, where the collisions do indeed resolve. And you could do more sub-steps, like I said. But this is fine with me. And all of this is ultimately to set the position. So I'm going to take all this, and I'm going to call it resolve collisions. That's what it does. This is our point grower. But before I turn that into a node group, there is something I want to do. So remember how I said every 5th frame? If it's every 5th frame, I want them to grow 5 times slower. Otherwise, they go a little too fast. So I'm going to take some number. So let's say they have a growth rate of 1. And I'm going to divide by that same number. that way it's kind of proportional. And this number 1 is like absolutely huge, right? But you can see if I make it every first frame or every other frame, do they grow at the same speed? Does that make any sense? They multiply 1 divided. Oh, maybe it's a multiplication. No, it definitely isn't, as you can tell. Okay. Either way, it should roughly follow this rule. I might think about it. Or they could grow every 5th frame or whatever. But this, let's make it a node group. So we have our frame number, which is going to give us a random spawn point near the middle. That's going to be dependent on this like randomization parameter, and then we spawn the points. Okay. So all of this, I believe, should be a node group. And maybe also the join geometry. So this could be something like spawn new point, where it takes in the geometry and it outputs something with 1 more. And then this input can be our, what does the input do? It's our radius and it's also our spread. So I can call this spread. So right now with the spread of 0, we get this issue where they're all perfectly overlapping. With the spread of 0.1, we get that. Whereas with a spread of literally 1, we get something like that. And we'll find whatever that number should be. Additionally, we have this set point radius, which is our grower. That can be a node group. So this can be grow radius. By the way, I'm overheating. I'm going to swap shirts. Talk amongst yourselves. I will put this on the screen. Be right back. Okay. We're back, and we're cooler. Okay. So where were we? We were cleaning up the node group. Let's get clean. So this is our delta time, which I did make a node for. And it might be a cleaner way to do this. cgmatter.com. I think that is a cleaner way to do this. So that is the top socket. I'm just going to put that in here so that we don't need that input. And then this other one is going to be our does it grow a point. Okay. So this is actually a Boolean, interestingly enough. So it either adds a point or it... No, wait. Yeah. It's a Boolean. Am I tripping? It's a Boolean that multiplies. What does this represent again? So we have the frame. It's a 0 or 1, and that dictates the growth speed. Oh, this is just wrong. This is just wrong. So if we go every 5th frame, it should be the frame number divided by 5. So what I mean... Wait, does that make any sense? No, it should be the growth speed, okay? So if it's 5, I want it to be 5 times slower, okay? So we can call this our, like, spacing in time. So maybe, like, our interval. And then that has a certain growth speed, which I can call, or sorry, like a certain radius. So maybe like, I think speed's fine. And now let's test this. So now we have something like that. If I bring the speed down to 0.1, we expect them to grow slower. Yep, that seems right. Day 5, hydraulic erosion. What is day 5? Feather. No, it doesn't fit. Okay. So we have our grow radius. We have our modulo, which I want to throw inside of here. Yeah. So I'm going to throw this inside of here and make this a parameter. Yeah. And make that a parameter. That swaps the use there. Then I don't need that anymore. And again, this is going to be our interval. And let's see, what does this look like? Okay, so far pretty clean. So what I have is I have some interval. So if this interval is 1, it's going to create a point every frame, or maybe every other frame. What if it's 0? Yeah. If I set it to 10, it's going to do it every 10th frame. This will make the collisions resolve more nicely, but much slower in terms of growing seeds. So I take the number, I spawn a new point based on that interval, and based on some spread, how compressed is it relative to the center? Like, do they all grow exactly in the middle, or is there a bit of variance? Then they will grow on every single frame and then fix their collisions, which we might reverse, but that's fine. After that simulation, we're then going to cull based on distance. So the seeds end up kind of looking like they're contained inside of a circle. And the only parameter we care about, of course, is the radius of that effect. So if I make it really tiny, it's going to start deleting points in the middle. I'll set it to 4. So cull points. And then this one's more so a visualizer. So, I mean, eventually we are going to instance something, so let's make this our visualizer. And to make it nice, set shade smooth. Okay, super clean, super nice. So now that we've set this up, let's actually like finish this part. So as for the number of seeds, it looks like there's, let's see, one in the middle. So let's say roughly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll call it 10 layers if you think about them as rings. They're not, they're a spiral. You could also count the number along a spiral. But generally, I'm going to grow this until they're like 10 rings. And additionally, I'd like to grow the radius much slower. So now what we can do is we can run a simulation and then figure out roughly how many frames does that take. So I'm going to bake. That was super fast because it's a super fast operation. And let's go. So let's see, how many rings is this? This is like 1, 2, 3, 4. That's a little much. I think it's around there. I think it's around there. So let's call it like frame 750. But I do want these to be a bit smaller. Let's see what this gives us. One, two, okay, a little more. Let's call it 850. Yeah. That looks roughly correct. I think there's even more. Let's go to 1100. Okay. I think that's plenty. So we do that, and then I'm going to call to make it a nice circle. Just a little. So before, after. Are there even more? No, I think that's pretty good, actually. And then I'm not going to keep these 1100 frames. What I can do is I can then bake this on frame, 1100. So I'm going to bake this, connect this, and then I don't need this to be a 1100 frame sequence. Although, what's the harm? Let's just keep it like that. So now I can go to frame 1. And, okay. So we call points and then we visualize them. So I think the next order of business is to get the shape right. And it's almost like a beveled cone, I think. And they kind of face the center, which is also interesting. You can see they're kind of converging there. People are saying there should be more. Let's do 1300. Clear the bake. Resim. Bake on frame 1300. And call. Okay, I'm happy with this. This is fine for me. So now, what we need to do is we need to affect the visualizer, and instead of a sphere, I need to let this be something custom. So now, we are going to be modeling a seed. So I think the easiest, so it's almost like a sharp teardrop, right? So yeah, here's what I think I'm going to do. I'm going to start off with a cone, which is almost correct. It literally just needs to be more like, smooth and teardrop shape. So I'm going to make that 200. And let's look at the geometry. So I'm going to add more geometry because I only need to do this once. And to get this bottom part to be kind of smoother, we know that we can blur position, cgmatter.com for the nodes. And the more I do this, the more kind of teardrop it will be. But also, I want this to be most effective on the bottom and least effective on the top. That's easy because if I look at the height of this, like the Z field, I can normalize this and then have the weight be based off of that. So I'm going to use the normalize field node that I made. What is the field? It's going to be the position, such that we're looking at the Z component. So this is going to be a 0 to 1. It's the opposite of what we want. So it smooths at the top. And I just want to invert this. So I normalize the field, and then I map range 0 to 1, 1 to 0. And then if I want a bit more smoothing on the top, I increase 0 to some number. Like that. That's pretty good. So I think triangles is the way to go. Set position doesn't like that n-gon. So that's a nice teardrop shape. And we can always edit this later. But this is what's going to be instanced. So let's see what that looks like. We need them to be bigger, obviously. So that is just a simple transform. Get them roughly the correct size. And then I also want them to point inwards. Again, you can see that in here. So to point inwards, I just need to change their orientation such that, you know, if we're looking at this one over here, it looks at the center. I don't know. Aligned rotation. I never know if it's a X, Y, or Z thing, but I'm going to look at its position. Normalized, although I don't think that matters. I'm going to plug this in here, and just play with these numbers. That is the wrong place. It's inside of here. So I'm going to pick some rotation. It will be this rotation. And that seems pretty correct, minus facing the wrong way. Okay, good. So I'm going to take this position, and I'm going to invert it by multiplying by -1, although maybe... So they're all pointing there, but also like the ones in the middle are doing it more so than the others. So you can kind of see this factor of how much it's doing that. That should be based on the distance to the center, right? So I'm going to take the length, which is just the radius from the center, and this is going to be the inverse effect, right? So can this go above 1 is the issue? Yeah, that's the issue. So I'm going to take the length. I'm going to normalize the field. And again, if you're just tuning in or not, just some promo. All these nodes you're seeing, Squarespace down temporarily. Squarespace is down, but they're at cgmatter.com. So I'm going to normalize the field. And then just like before, I'm going to invert the field. That's pretty good. And then I can shape like how this happens or something like that. And it looks like they're doing it a little too much. But that it definitely captures the idea. It might need some work, but that definitely captures the idea. Another thing I'm seeing is these aren't like circular. In fact, they kind of look like pentagons or something like that. So inside of the cone, I can change that. And what is the issue here? Why does it not like? The number of iterations. The less geometry, the less iterations here. So I'm going to do a pentagon. And instead of that, I'm going to keep the iterations, but I'm going to lower everything else, and I'm going to add geometry just by subdividing. So you can see every subdivision, it's getting closer to where it needs to be. Maybe this isn't the way. Maybe we just want to do an SDF. Like this kind of captures it. Yeah, I think what I'm going to do is I'm going to turn this into an SDF so the geometry is pretty like normalized. So very simple. Recently, I've been doing the magic of like SDF to mesh to SDF and then backwards. I do also have a remesh node, which works fine. Why is this so weird? Oh no, that's fine. Then I blur position, more iterations. That's closer. No, that's pretty good actually. That's pretty good. And now I can change the number of vertices. So let's see what that looks like. I think that looks substantially better. And then I can also add some like randomization so it doesn't look like perfect. So I'm going to run a distort node. So this is just going to modify the shape a little. And now you can see that's pretty good, but they're all kind of facing the same way in terms of the Z axis. So if I was to add a rotation here, so let's see if I increase the Z. Yeah, that is what I want randomized. So I'm going to random value. I assume there's no rotation, but a vector is fine. And I'm going to give this maximum Z variance. And then also maybe a little on the X and Y, right? So maybe like minus 0.1, 2.1. And that already is looking much more organic to me. Make the rotation dependent on the distance from the center. I'll consider it. I will consider it. But that is pretty good. Let's just see. This is also a super cool pattern. Okay. So that can always be modified later. So all of this needs to be a node group that basically is a instance at the end of the day. 1 second. So I'm going to take all of this, turn it into a node group. This is going to be our seed. And then all of this logic inside of here that dictates the rotation should probably be inside the node group. So I'm just going to get rid of that. I'm going to plug this into the rotation. So even this can be a node group. It can be called rotation, or maybe seed rotation. And then that is going to let me get rid of the rotation socket. So now that is much cleaner. We have our visualizer, and this time we're plugging in a seed instead of like a sphere or whatever it may be. And then inside of here, I can pick what controls do I want over this. Maybe like an octagon. What controls do I want? Mainly like the blurring. I believe. No, that's pretty good. That's pretty good. Okay. So, all of this has been our seed. What am I doing? What am I doing making frames? This should all be a node group, of course. So this is a node group where for each of these I choose the parameter. So this is the input, and then I can flip the geometry to be on top. There we go. Nice and organized. So this can be our distribution distribution simulator to indicate it is a simulation zone. There we go. And then we bake it and we visualize it. I'm happy with that. I love organizing my nodes. For anybody asking what we're up to, today's prompt is bouquet, and I'm doing a sunflower bouquet mainly for the fun of making a sunflower, really. Okay, so now let me bring in more reference, like this one, which I really didn't like. I wonder why that's the case. Is it like a weird file format? Oh, it's like a UDIM something or other. Don't know much about how UDIMs work. I just want this image. Don't use UDIMs. Just bring it in. Okay. So now that we have that, the next thing I'm seeing, so we have those like central seeds, and now we have these pistils, I think is what it's called. I took a biology class one time. They're kind of just like a hair system, really. I don't know if that follows the same rules or if those sprout out of the seeds or something. It kind of looks like they sprout out of the seed at some point. Let's get rid of that. Okay, we can do that. So to do this, this is just going to be a lot of instancing. So I'm going to do a mesh circle that is roughly the same size. with a lot of geometry. And on that, I'm going to distribute a bunch of points. And let's just kind of join this together. So this should be much bigger. Even bigger. And ironically, we're trying to kind of do those Fibonacci spirals, which we use collisions for. Poisson disk would be like an approximation of that. Funny enough. Okay. Like, I don't know if it generates the spirals, but the fun part is the simulation, which is going to be in my render, is what I plan to do. So this is going to have the sprouting things, whatever they are. And to do that, I'm going to instance on points some kind of pistol, I think is what it's called. And that can just be a curve, because I think a curve would be easy. Or, like, let's get some other reference. So, sunflower up close. I just want to see what those things look like. Ooh, that's some good reference. It turns out they're quite pointy. Let's actually include that into our seed. Quite pointy. And then for the rotation, they should be more intense at the beginning. Okay, that was good to know. Okay, so it kind of looks like a line with a little sphere, a little distorted sphere on top, and then like little hairs everywhere to be sticky for the bees. I think it's still fine to do this with a curve line. So that's what I'm going to do. I'm going to use a curve line for the instancing. I'm going to make the size somewhat random, which will just kind of correspond to the height at the end of the day, but just a little. Then on average, taller. And then just like the things like the seeds, they should kind of open up, which we could do after the fact, and I'll consider doing that. But yeah, for the rotation, let's do something quite similar. I wonder if we can even reuse this. Rotation. It's not seed row. Oh, no, it is. It's definitely not exactly that, but those are definitely the parameters I want. Or I need parameters, but that's definitely the node group I want. So let me just expose these and then use that for the shaping. So before, after, okay. And then, should I model the curves inside of here? I guess so. So let's see. I'm going to run a curve to mesh that needs a thing to sweep along it. This can be pretty low res unless we're super up close. And then they had that little sphere up top. So I think there's a lot of ways to do that. I'd like it to be a single curve. That would be nice. So what if I resample So this curve is super high res, which yes adds a lot of geometry, but it's only to a single instance. Let me just isolate that here. What this is going to let me do is I can play with the scale dynamically based on the spline parameter, which is normalized along the curve. So here you can see it starts at 0, infinitely thin, and it gets bigger. But are geonodes finally stable to learn long term? They were stable to learn years ago, I feel like. But thank you for the thing. I said in the, what did I say in the goal? 1 teal super chat, I dab. I didn't mean it to be teal. I'll give it a little one. Thank you. I feel like the kinds of, like, I feel like there's people who are like, is Blender industry standard? Is like, I don't even know what that means. Just use it, you know? So float curve, I'm going to go up. And then how do I want to shape it? How do I want to shape it? Well, maybe let's start off bigger to begin with. And then it can kind of grow. And I want to make this bump at the end. Like, that's my goal. So relatively, it needs to be like that, so we can have that like bump at the end. Can you kind of tell what I'm going for? And then I can do a bunch of distortion inside of here. There's probably a smarter way to do this, but I'm just gonna add a bit of variation. That's the thing. At a certain point, it doesn't want me to add new points. But this is better than nothing. Okay, so now we have some basic shaping. It will end up looking like this, which is much better than what we had before. And I'm also going to fill caps. Oh, thank you. Corridor crew, I got nervous. That's what I felt. It was very nervous. I was very nervous about it, and it was also very soothing in that you kind of know what to expect. You've seen a lot of them, and they're vaguely similar to that persona. Okay. So I want that, and I also want to distort the spline parameter a little. So what if I take the scale? I'm going to use the spline parameter to drive a one-dimensional noise texture. And so far we've been going for an hour, so this is pretty good progress. So I'm going to do a one-dimensional noise texture, which I want to normalize. Is Squarespace back up? Yeah, it looks like they just had a temporary outage. So again, cgmatter.com, just type it in, go to free nodes, and that's where you can get them. And if you're so inclined, you can get the Nodevember files as well. Okay, so I'm normalizing the noise field, so it goes 0 to 1, and then I want to add that contribution. Maybe I want to multiply it, I don't know. But that just adds some variation that I believe, so now we have that detail. I believe I only really want that towards the end. So I can use this map range now that I know it goes 0 to 1, and I could bring this. No. I want to multiply by the spline parameter. Do I just want to multiply, period? No. I'm going to multiply by the spline parameter so that it becomes more effective at the top. So this is before and after. And then I can, again, run a float curve to really shape that. So it kind of mainly affects at the end here. Just like that. Okay? And then for the quality of the noise, of course, I'm going to fix that. So something like that. And then this should have a tiny contribution because it's kind of ridiculous right now. Okay. And then I think finally, just kind of like as a cheap trick, a cheap little party trick, I'm going to run the distort on top of everything. Just subtle. Before, after. I would even bring that down more. Before, after. It just adds a little bit of something. So now this looks more fragile and delicate, and we get something like that. Not bad. I think, I can't tell if these grow in the middle of the street. Again, I think this sprouts from the seeds, if you can kind of see that here. So I imagine they become more prominent as they go outwards. So let's do that. So again, I'm going to look at this scaling value. And I am going to do something with that. What do I want to do? I want the scale to be dependent on the distance. So let's take the position. Let's take the length, which will tell me the distance from the center. And again, I'm going to use that normalized field node, which apparently was a really good idea to make. Who knew? Like, I kept using it, so I went back and added it. So I normalize field, and then I'm going to multiply based on that contribution. There you go. Can you see what I'm doing here? And then that in itself can be multiplied by something like 1.5 to be nice and wide. And then let's play with that rotation a little. Yeah, it's pretty good. Okay, so we can always modify this later, but I think all of this should be inside a big old node group. So I'm going to call it, I don't know if it is the pistil. Let's see, flower pistil. So let's see, it's these lines. So the filament, the stamen. It kind of looks correct. I think the pistil is just the tip of it, maybe. Or maybe it is the whole thing. Okay, I think pistil is at least nearly correct. So I'm just going to use pistil. Yeah, if you go to the Corridor Crew channel website, you can see it. And also, if you want to read about it, dude, Squarespace, something's going on with Squarespace. I don't know. But if you go to the blog on my website, which is free, there's a Working at Corridor post. The whole gang's here. Okay, so what did I just do? This is the pistol, but it's not spelled like the pistol. It has an O, the gun, you know? So that is the pistol. That's going to be our scale. And okay. So remember, all of this is still dependent on our point distribution that I can always make more dense by decreasing the distance between them, which adds a good hit of detail. Additionally, you're going to see that some of these are sprouting in the middle, which is kind of what I want, but it's a bit intense. So for this normalized field, just like I've been doing, I'm going to run this through a float curve so that it's kind of nullified in the beginning. It's kind of nullified, and maybe it even expands more outwards. I think I'm also going to float curve this one. That way the rotation is a bit more dramatic. So before, after. Okay. So now I think I'm happy to continue. Okay, so this is going to be a node group. It's going to be called our pistil instancing. And now we can go back to our very tidy node group that actually shows what's going on. And then inside of pistil instancing, just going to clean that up a little. Nothing crazy. And a lot of these could be parameters, but I don't think I'm going to mess with them. So I'm just going to feel fine with compressing them. Hey, Daniel, the craftster. No Philoticus, though. I am out of my depth when it comes to the biology here. Okay, and remember, you might be thinking, how does this all result in a bouquet, which is the prompt? Once we do this, we have it, and then we can just instance it in a vase or whatever. Okay. So now, kind of the last step is the petals and throwing it into a flower. One thing I'm noticing about the petals is it's not necessarily the simple shape. It also has these lines, these divots that make it look good. So let's model the thing. To me, the easiest way is actually to start off with a curve, which might sound weird. So here, I'm just going to zoom in on a petal that we want to make. We need to kind of get this oval shape. So what I'm thinking is if we start with a quad, and then I cook it, I fillet that bad boy, we can get kind of close. And then all I need to do is kind of squish the things. And let's just do something like that. I'm going to resample the curve so it's nice and detailed. And what that will let me do is it will now let me shape it a bit more easily. So to shape it, I'm just going to set position, like I always do, and just like we've done basically throughout this whole live stream tutorial. I'm going to look at its height, its Y component, and then squish parts, expand parts, squish parts based on that field. So let's take our position, looking at our Y component. I'm going to normalize it so that it goes nice and 0 to 1. That's the wrong normalize. And then based on that, I can squish it. Now, we might even, can we run scale elements nodes on a spline? Can I type scale elements node in my head? No, you can't. So I'm going to take the position. I want to squish it on the x-axis, which is the same as multiplying, but only on the x-axis. But then I do that based on this normalized field that I'm going to shape. So 1, 1, and then this. And you would expect to see this shape right here. The reason for that is here the y is 0, here it's 1, meaning that here it gets scaled on the x by 0, it pinches, and here it does nothing. And then finally for the shaping, this is where we use that float curve. So it does end at a point, but kind of more neatly than that. And it's kind of the biggest in the middle, and then it shrinks once again. But there's kind of like a little tiny little pinch right there that I like. Can I get it like that? I think that was it. I just need more geometry. Yeah, you can see that there. It just needs to be softer. There you go. And does this feel right? It does. The only thing is it kind of flattens out on this section. So it's all that artist touch, you know? So now that we have that, we are going to use this as a basis for modeling. So as always, let's throw on that distort, which might be better to do after the fact. I need to think about it. But either way, this distortion should only be on 2 dimensions. I don't want it on the z component. So inside this distortion, can I add a node? No, it is packed. So I'm going to hit that. And I'm going to take our source of randomness, which is the noise, and multiply it by 0 on the z. So now it's just, you know, being weird. It's glitching out there. Bring down the strength. Bring down the scale. Yeah. Do you feel it, Mr. Krabs? There's a beautiful connection between geometry and nature. Please have a quick look. Interesting. Yeah, I know I did the Fibonacci part either correctly or, you know, in spirit correctly. Don't know much more than that. So here we have this. I'm going to fill the curve so it's actually geo now. But the big issue with this is the way it does this, right? So let's see. If I do an n-gon, do I have poke faces? No. I have subdivide. Like, we can get geo, but it's like distributed in this like super shitty way. So I need to kind of get those nice grid geometry on this. There might be an obvious way to do this, but to me, the most obvious way is I start off with the thing I want, which is a grid. And I kind of want to like overlay this on top of that, if that makes sense. And that will let me do all the things I want to do. Another option is I could give it thickness, which might be easier, actually. I think that would be easier. So I'm going to take this fill curve, which is just a infinitely thin thing, and I believe also a instance, weirdly enough. Nope, I don't know why I was thinking that. Maybe it used to be. I remember that. I'm going to solidify extrude, cgmatter.com. That's going to let me give it thickness while keeping the bottom. And then I run a remesh on that. So what this lets me do is effectively get that nice geometry here that I can more easily get these lines and various things. And we're only going to make 1 or 2 petals. There should be a bit of variation, so I don't need to go ham. But now what I want to do is I want to get these lines here. These lines. Could I do it manually? Yes. Could I use wave texture? Also yes. So we just shape this wave texture. But it also kind of needs to bulge in and out. We'll figure that out. So there's less lines. There's more distortion. And I kind of need symmetry while also keeping the gaps. Okay, well that basically, well before I do that, let me just check what I get with these. Ooh, that's kind of nice actually. Okay, well before I do that, we can distort this by taking its position coordinates and manipulating them. So again, I'm going to do the same trick. I'm going to use my normalize field on the Y. This will let me shape it. I multiply it just like we did before. Or I could actually have it based on the distance to the edge. Huh. Okay. So I'm going to take this. I'm going to combine X, Y, Z. And it's the X that I care about here. So let's use that normalize field. See what happens if I do it on the X. Yeah. Okay, so once again, I can shape it. In fact, I might want to literally use the same curve. No, it's that, but inverted, I think. Okay, so I'm just going to reset this bad boy. And I want it like this, but pinching? Yeah. 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 Like that. Okay. And then this should, the whole point of this map is it will very subtly push this downwards and give it a bit of shape. Hello, duck. Thank you again for the money. Ever tried Hunyan 3D AI model for 3D model gen? Absolutely. I actually used it very sparsely on that wedding video on the blog post to make the megaphone. Very cool stuff. I did it in Comfy UI because I think it was very easy to do it that way. I also think I did a sponsored video, but it might have been different. No, I think that was like, oh no, Tencent does make that. I'm not sure. Either way, I'm going to set position of this remeshed version dependent on this wave texture, such that I move the Z up and down, just like that. And then it's just a matter of picking those right numbers. Okay, so you can kind of see what I'm doing here, right? So I either do this or the opposite. I don't think it matters. I think it actually goes upwards. And I can also reshape the wave. So here you can see we have a sine wave. Here you can see we have a sawtooth wave. Here you can see we have a triangle wave. I never use triangle, but I think weirdly enough, this is one of the moments where you do want to use triangle. I'm going to use a power node to kind of modify this curve. Oh. Oh. That should be before, shouldn't it? By the way, this also moved on the X and Y probably, didn't it? So I want to make sure I vector math. I think I basically used floats instead of vectors is what I'm trying to get at. Okay, so we have that, and the power will let me kind of sharpen if I wanted to, and I do. Okay, that is our petal. And I need this to be super subtle. Okay, so this is our petal. I'm going to thin it out because it's nearly flat. And then I want to shape it such that it kind of has that nice sprouting outwards curvature, and then maybe it also like folds in on itself, right? And I could do the standard where I do the normalized field, or I could get fancy. I think I'm going to get fancy. How am I going to get fancy? Well, remember, all of this is dependent on this curve that we made. So this curve turns into this. Well, what if I turn it into a mesh? And for this petal, I look at how close is it to the border, and then bulge it out depending on that. Okay, so let's see. What does he mean? What does he mean? I'm going to take the geometry proximity. Oh, don't need curve to mesh. It's already a mesh. I'm going to find the proximity to the nearest edge. And you can see that kind of creates this map here. And what that map will be used for is pushing things up or down or even all around. So let's combine X, Y, Z. Like that. And there you go. Of course, we want to flatten this out. And we can by modifying the distance map. I think the easiest way I found recently that I've been playing with is using the power. So high power compresses it, low power rounds it out. Although you can see it goes up, and that's because the distance is not normalized. So another field normalize. Huh. And then I multiply this by a tiny number. So let's see. Kind of. Okay. Clearly, this is not the approach. Let's try a float curve, see if that does us any better. I just like the idea of this approach. If it doesn't work, then it doesn't work. But I think that works. And then what I'm actually going to do is I'm going to take this wave texture idea and do it as the last step. That way we don't like blur out our detail using this proximity idea. Yeah. Nice and thin. And like that. Okay, so this is what we started with. And look at us now. Barely any change. Okay. Last thing I want to do is, like I said, I want to add that arc curvature. You already know. I know you already know. So I'm going to also add a contribution, and that contribution is going to be dependent on its y-axis. Reason being is I want to say, as you go along here, bring it up or bring it down. that makes sense. No, along its y-axis. There you go. So now it's going up like that. We shape the bad boy as per the usual. And then it can kind of blossom out however we want. We could even get fancy where it does this kind of curve. But I think it should be super subtle. Yeah, like that. Maybe with the tiniest bit of wave. Just tiny. Tinier. I like that. I'm going to multiply its contribution and then I'll clean up, I swear. I think I want a little bit more flare at the end. And all that work to make a nice looking petal. And I think the only problem with this is, I don't know if there is a problem with this. I think the problem with this is we have it inverted. Because I want the tip, you can see the tip, to be kind of the highest thing. Okay, we can always change that later. So this whole monstrosity was literally just to make a petal. So let's see what we can do here. So this is our curve. We then did a set position to kind of distort the whole thing. We then did this, or we did a shaping and then we did a distortion. I solidified and I remeshed. So just so you can read this, I had a quad. I filleted the quad. I shaped the quad. I distorted the quad. And I turned it into this. And then the rest of this is just shaping. And notice there's these patterns where I have like what coordinate I'm isolating, a float curve, and then a set position. So you're going to see that is pretty common. Okay, we got our wave texture. We got our power. So you're going to see these stacks of 3 quite often. Here we thinned it out. Here we did that proximity trick. It might make you think maybe I should make a node for this because I use it all the time, this like triple stack. I'll consider it. And because we did all this, if we did a for each zone, instead of instancing the petals, we can make each petal a little unique. But as you can see, yeah. Okay, so all of this is a petal. It's a pita. It's a pita malak. It's a petal. Great. Probably should save Nodevember, day 4, Bouquet. Bouquet. Okay. I like that. So we have our thing. Let's not forget what we worked for. And now let's finally add those petals. I'll see if instances do it for me. Will they do it for me? And if they do, great. So the petal, I am finally going to transform such that this is the origin at world origin. It's just going to make the positioning so much easier. So I believe should be by 1. Yeah, -1. Because the original quad had a radius of -1 on the y. Okay? Now we do a mesh circle, and you instance it with 2 layers, it seems, exactly how you think you would. So instance on points, our petal, and to get the rotation, you look at where they are relative to the center and rotate them outwards. Now, normally I like to do a curved circle so I can use the tangents, but I've never tried aligning to the position, and I'm curious if it works. Hey. Okay, so let's... Interesting. Is the y-axis correct, just inverted? It is. It is. So how many petals are there? We can make this realistic. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I don't know where I started, but roughly 14, and there's 2 rings of them. So I'm going to make 14 petals, and what makes this look good is the variance, I imagine. So I'm going to do a random value for the scale. They should not be able to get that small or that big. Let's see all of this in context. So I'm just going to join it. Okay, clearly this is too small. So I'm going to bring up the radius for where they even spawn, and then I'm going to scale up the scale. Like that. Okay. Okay. Another thing that makes this look interesting and not like the reason this looks so weird is you're going to see that this, like if you isolate one ring, they're not perfectly spaced. They're not like perfectly distributed along the circle. So I think if we emulate that, I think even on the z-axis a little, it'd be nice. So you can see that this is like that bunching that I'm talking about. That bunching. I'm also thinking let's take the pistil and make it a little wider. I think would look nice. So it looks more full. Okay. Now let's add some randomness to the rotation. So that can be done by using our vector math. That's so not true. That can be done with our random value. We're not even at 2 hours. I think I'm making good time. Okay, so we got something like that. -1 to 1, so fully random rotation. I'm going to scale its contribution so that I can easily modify like the overall strength. Okay, so this is 0. I'm going to add a little here. And what's the one that's doing this like really insane like spinning? Let's find out. It is the X. So X is like that, or it's also the Y, and then Z. Interesting. It's kind of all of them, isn't it? Just going to try to find that correct number. We can always modify it later. So let's see. The petal on my screen is roughly the size of the whole interior, which I think we captured. I think 14 is quite dense. I'm going to bring it down to 12. And I'm just going to take this, and instead of like duplicating and making like a second ring underneath, I also want that to be like subject to this. So I can actually take my mesh circle. I can make 2 of them. Okay? But the difference is this other one, I'm going to bring beneath. Right? So it's like beneath it. Maybe like rotate it a little. It could be a little off axis. Whatever. Okay? And then let me see these circles. I think one thing that's making it extreme is it's looking at the direction. So I wonder if I so right now these circles are 3-dimensional. I wonder if I flatten them to 2-dimensional, if the rotation won't be as insane. So I need the direction relative to it having no x-axis. So let's see. Without, with. I'm not saying it looks better, but that is correct. Then to do the tilt, I can even add something. Yeah. You see that? That's that flower opening up, and that's the difference between like a sunflower and a nunflower, you know? Yeah. Okay. Cool. So now the question is, why is it so intense when I add? It's because of the amount of distortion, clearly. Or maybe not even. Interesting. It's not even the randomness. Okay, so I'm going to get rid of this for now. And to open and close it, how about instead we modify our pistol to be tilted up and down? So I go to my pistol. I'm going to rotate it on the X. I'm going to rotate it on the Y. I'm going to rotate it on the Z. I think, so you see how this X feels incorrect? I think we need to do this after we do our translation and scaling. Don't know if that's true. We'll find out. So transform geometry on the X. Yeah. There we go. That's the money. We've inherited the money. Okay, great. So we have something like that. And remember, we started off with a little cube. So we have that. I'm thinking the petals ought to be a little bigger. And maybe the second one can have more petals. Now you're going to see this petal-to-petal intersection. You could resolve that like we did with the seeds, but I'm just going to bring it lower and hope for the best. Okay. I think the last thing that's kind of barring this from the petals from looking correct is every petal is identical. Every petal is identical. So without doing too much work, I'm going to keep this instancing approach. I'm going to create some variations. So I think the big thing is if I go to the distortion, that's like the big thing that makes them look different from each other. Okay? So I'm going to add some parameters, mainly for the distortion. I need the strength, the coordinates, the scale, the detail, and the roughness. So this way I can make two different petals. So this is going to be petal number 1. And then for petal number 2, I'm just going to play with this a little. So maybe this is one that's quite straight. It has like micro detail. 1, 2. Okay. Let's make a third variation. This one can be more similar to the first one, except I'm going to shift its coordinates. These coordinates are solely for the rotation. The reason I do this is instead of using a 4-dimensional noise, this is like a faster way to compute what I'm going for. Okay, so these are all different. I'm making each one an instance. The reason for that is the pick instance thing here needs a list of instances. It doesn't like geometry. So that way it can pick between, in this case, 3 instances. So if I do this right now, it's going to just overlay, I imagine, a bunch of stuff. Either way, turn on pick instance, and now they shouldn't all be the same. We can verify this by making one of them like super unique. Yeah. Okay, so they're all different from each other. Now this is also something you can do for with the for each element. That way they're all truly unique. But this is fine with me. I'm also going to add a group input that lets me control the overall scale. This is nice because some petals ought to be wider than others. And then also maybe some petals are more curvy than others. So remember, this rotation was our like, you know, it was that. And I think that's going to be a big one actually. So I'm going to make it something like that. Again, we're just going to hope for no intersections. Okay. And then finally, no, I mean, that's good. That's a good start. We haven't even done shading, which I think is what's going to bring it all together. Whoops. Did not want to do that. So here we have our 3 options, and you can add as many variants as you want. It's not going to be too expensive because you only calculate them a single time. And you can think of this as our like pistil variants. So that way we have a few of them. I can call this our variants. Everyone's nice and happy. Here we have our spawners, as you can see. So what we'll see, how full do I want this to be? It's kind of looking sparse. Like, should I make the bottom ring insane and hope that there's no collisions? Maybe. Will all the streams from the Nodevember challenge be saved? Yes, they will. They're uploaded as video on demand like an hour later whenever it's done processing. Size ratio between things looks wrong. I could believe that. I'd definitely be willing to bump it up a little. Okay. One thing we're missing, clearly, is we have like a big gap here. And honestly, this is just the base, so I think I'm going to be lazy with it. I think that's what I'm going to do. But first, let's make this all a node group. We have our pistil variants. We have our scaling. And then here, we have our nice rotation. Oh, we didn't even use any of the randomization yet. Yeah. So let's see. 0.1. Too much. 0.02. That seems to be super strong, huh? I wonder if instead what I do is I add it after the fact. That seems to be a bit better. Yeah. That's a bit better, but now the chance of collision's super high. But it might be worth it, just a little. Yeah. Okay. So this is our rotation. Which maybe I want to keep this exposed. This is always going to be the same. Again, it's these stacks of threes that keep showing up. Okay, so all of this is going to be our petal instances. Petal. Let's go back here. I want the petal variants exposed and the rest to be a node group. So this is going to be our petal instancing, which I think I got the names wrong here. No one corrected me. Maybe they did. I didn't look. Okay. 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 So what do we got? We got our procedural seed spawner, which was just cool. We have pistil instancing. We have our petal instancing. We join them all together. And then, like I said, we're kind of missing a circle here. So I'm going to be lazy. I'm going to do mesh. What am I going to do? I'm actually going to do a cone. What is he thinking? A cone? A cone is a good way to get, if I look at the top view, it's a good way to get a circle with these rings, because eventually I will distort it. The secret's out. So I want to make sure that this circle either does or doesn't exist. So I'm going to delete geometry, the top. That leaves us with this that I can... This one? Yeah, there you go. That little thing would be a nice, convenient node group. Okay, and then that gets joined on the bottom. Okay, that's the minimum size it has to be. Let's add some geometry, because we're only doing this once. And now we have a good base for our sunflower. Now you might be wondering, why did I add all this geometry here? Well, there's one final trick. There's one final trick. Is the pistol thing too tall? I haven't a clue. But if it is, it's easy to modify. Okay, so what's the punchline? The punchline, ready, is we have all of these vertices. Mainly what we have is instances. I wonder what happens if I realize. Will we crash? 24 million. It's not bad. It's not bad. The punchline is I wanted to take it and radially raise the middle, so it kind of really blooms. Now, what I'm seeing is a lot of geometry, and I wonder where it comes from. Does it come from the pistol instancing? It does. It does. Now, why is that the case? It's probably because the pistol is using a super high-res thing that it doesn't need. So if I turn this down to 3, you can barely even tell, and in a way it almost looks better. So I'll set that to 6. Now, so we were at like 12, 12 and a half. Now we're at 4.8. That's great. What about the petal instancing? 1 million. Not that much in the grand scheme of things. And this is another big boy. Okay, let's fix that up. So here we have 10 million verts. That is a consequence of the instancing, so the visualizer, but I had the instance that came from the seed. Okay. And that is because this resolution was too high. So I bring it down to 100, all of a sudden we're down to 200. Sorry, to 2.7 million as opposed to 10 million. And, I mean, they're so small. Like, can you tell? Nah. Nah, you can't. Okay, so that's pretty good. And then with that, I can totally scale the radius a little so that they have something closer to overlap. And now what do we got? If I realize everything, I think it was like 25 million. Now we're at 8 million. Okay. So we're at 8.4. Where is that coming from? Half from here. Okay, I feel like this is the biggest offender considering the thing is so small. So maybe I do all of this the way I like it, and then I do another remesh. Yeah, that is nearly identical and brings it down significantly. Yeah, you can't tell. Okay, big savings, big savings. And now we're at 6 million. Now the next biggest offender, like we said, is the pistol instancing, and that was half a result of that thing we fixed, and half a result of the resampling to 200. So let's see, if I sample to 100, yeah, that exactly halves the detail. And then, weirdly enough, we only need detail at the top. Okay, but that's already much better. Like, it's not insane to manipulate 4 million vertices. And now, like I said, the punchline. I'm going to set position. Actually, what I'm going to do is I'm going to bake all this so we never need to calculate it again. So right now, you can see it's taking 120 milliseconds or so. I'm going to bake this a single time. Now you can see, you know, it basically loads. Like, it should play nearly or actually real time. So that's pretty good. And then I'm going to do that final punchline where I set position. Based on the radial distance. And that goes upwards. Or it does something to kind of bend outwards. What else do we got? Potentially dumb question. In 5.0, is lighting able to be manipulated with geometry nodes? No, except in the sense that you can instance lights. So if that's what you mean, then yes, you can instance lights. And I did that for the pumpkin video, the very first live stream. The cone is the key. Never thought of it. Had the thing with repeat and extrude. Yeah, big big revelation. Will all the streams be saved? Yes. Okay. So what I need to do is I need to take the position. I am going to look at its compress to XY space distance. Of that, I'm going to normalize the field. And then that is going to be used to move the z-axis. So this is going to be linear. Ready? Not bad, actually. I'm going to multiply this by a big number so you can actually see what's happening. So it goes like that, but you can see it's linear. It's kind of the straight line. And it should do this kind of like, almost like a nice arch. That is, I think, a float curve kind of thing. Oh, and it should come after the multiplication. Yeah, buddy. Okay. So this goes here, this goes here. It starts off like this. And now we shape it. So let's see. So maybe I do have it inverted. Maybe it does start at 0. Oh, there you go. But the bottom needs to be quite flat. There's a magic number somewhere in here. Okay, so I don't know if this is what we're going to be using, but before and after that nice curvature, nice curvature, and then, don't get me wrong, I love manual, but what if we added some randomness based on the two-dimensional noise like that? Yeah. Clearly, that's what I wanted. Okay, bring the scale down. Bring the scale down. And let's see. Before, after. Let's turn off normalize. Before, after. Oh, so organic.
So organic. So good.
I love it. Okay, so now we take it. We multiply by 0.5. Before, after. Money. Money. Although it is kind of strong in the middle here. It is kind of strong in the middle here. So what I can do is I can multiply roughly by this, and that will handle it. Before, after. It's everything. Okay? So this was our thing. You know, we generated it, but this is what makes it a flower. Are you planning to test the iPad version of Blender? No. I'm not a sculptor. I'm not a painter. I'm a technical artist. Okay. So all of this is going to be a node group. And now we can move on to shading. Although it's kind of a shame. It looks so nice. Okay. So this is going to be our blooming. It's like I really don't want to shade it. It's like so perfect. Well, let's before I go hard on that take, let's see what we can do. Nodevember, day 4, Bouquet. Okay. And this can be our scene where I put the camera and everything. Okay. So let's start off with a camera that I am going to, I think normally I've been doing these orthographics. I'm not sure if that's what I'll do here. So let's see. What does that look like ortho? Kind of ruins the beauty, doesn't it? Okay, I'm going to put this directly above. Move it upwards. This calls for my 4:3 render. And I'm going to make it a 30mm lens so we can get right up and personal. Okay. So do we want to shade it from this perspective, or do I want a bit of a tilt that's generous and shows the form? I think I have to show the form, otherwise, like, why do the blooming thing? So just to show the form. Ooh, that's it. That's the angle. Can always rotate this. Yeah, I like that. But ideally, again, I rotate the camera, actually. Yeah. It's going to be hard to choose. Okay, I think I'm happy with that. So, that is our camera. And now we need to start lighting. So let's do our good old sequels. I've been having issues, as you saw with the last stream. Yeah, okay, that's good. We have that, and now it's time to light and shade. Probably good to start off with just some basic lighting, and I think the color and everything will... that's nice, though. Will dictate the rest. So I'm going to start off with a black background. This is the way, because then you can really see what your lights are doing. So turn off all the lights. Get a point light. And bump that bad boy. I made this quite big, didn't I? But I like where the camera is. Okay. So you just find what feels right. It's all vibes. It's always been vibes. And because this is centered, actually, this is one of the great times to use... This was right. Center at cursor, or pivot on cursor. Okay. Time for light number 2. What will this light do? Ooh, I kind of like that. Although presumably the sunflower is in the sun. Okay, so there's a start. Let's just see what a sky texture looks like, just so I don't feel guilty. Because now we have the multiple scattering. So this was the previous sky. This is the new sky. I might feel guilty about not using that. Oh, Forget it. I'm using the sky texture. It's easier too. And Prestige. And Prestige. That's beautiful. Okay. I gotta. Whew. Okay, so I guess somebody had a good point. If I scale these together, it doesn't make a difference. So I feel like a sunflower, it's pretty big, maybe like a foot across. So I'm going to add a cube. That cube is going to be like a third of a meter. Does that make sense? A third of a meter across. So we might have made our sunflower a little big. So I scale it until it is that size. Okay. So visually nothing's changed, but now it's to scale, and that matters if I use the subsurf, which we gotta. So this, does anything happen if I apply scale? Does it break anything? It does. So I'm just not going to apply scale. Okay. So now that it's to scale, we need to make materials. Now the issue with materials is we need to know which is which. So this is how I'm going to do it. This is the seeds. This is the pistil. This is the petals. And this is the floor, essentially. And they all just come along for the ride. So I'm just going to make 4 materials. Let's do that. So this can be our seeds. This can be our petals. This can be our pistils. And this can be our base. Okay. So now seeds get the seeds. Pistil gets the pistil. Petals get the petals. And base gets the base. Now, I believe if I'm correct, we do not expect this to work out of the box. Now, why is that the case? We did this correctly. That is the case because we've baked. So we got to rebake. And then it will know exactly to use that material. So I think we work one at a time, obviously. The petals, I feel like, are going to be the easiest. Okay, let's figure out what the frickety is going on here. Okay, so the petals, they're thin, they're yellow, they're soft. And I'm just going to use my Chronos. I love my Chronos. Ugh, okay, never mind. I'm going to use my AGX. Somebody said, by the way, to match renders with previous working space as closely as possible, colors. Okay, whatever. I heard that this is the way to go. So we gotta figure out what we're doing here. This should definitely be the biggest. Okay, I think we're set for success. Okay, so we start with our petals that, we're going to make yellow and do things to them. So the first thing I want to try is all these things are thin. They're in subsurf mode, okay? That's how you make plants look good, it turns out. So subsurface, what's the color? It's like this yellow. Great. Looking disgusting. And then you want to... You want to take this and make it tiny? Yeah, that's what it is. Another thing people do is they also like translucency. Ooh. Ooh. Like, whack, yes, but nice. But nice. I think I'm going to actually combine this with whatever we do on the principled BSDF. Okay, so let's go for a yellow. Kind of like as vibrant of a yellow with a hint of orange as you can get. Are these petals, are they reflective? I feel like they are. Like you see that highlight? Okay, so I'm going to bring down the roughness actually. And then how much shine do they have? Do they have none? Do they have it all? I'm not sure. We'll figure that out later. Subsurf is now on skin mode. I don't know what that means. Okay. Oh, I see what you're saying. You're saying the default settings. Okay. So we have that. Does the IOR matter? It does, but I don't know what it is, so we'll move on. Subsurf's going to be important. Now transmission. Like it's not glass. It's not. But you can see through it, and that's going to be that subsurf. It's going to be that subsurf. So I'm more familiar with it inside of here. So let's turn it all the way up. And the scale is how much the light penetrates. So if it's big, it will penetrate all the way through, right? Like boom, all the way through. Oh, that's so nice though. So you want this to be tiny, I believe. And then this radius dictates the color almost. It's almost like too much. Okay. Another thing is I think, so the subsurf makes the lighting matter a lot. So I'm just going to pick something I like more. Like you can see how much that matters, right? Okay, this is already more flattering. Can we do better? Aerosols. There's going to be some aerosol. I don't know what that means, but there will be some. Okay, that's nice. We're at 2.5 hours. Good progress. Good progress. Anisotropy does, I feel like the reflection stretches, right? Let's see. Whoop. Oh, by the way, I totally forgot. Set shade smooth. Okay. So, does it stretch? Maybe. Maybe. Okay. So, it seems like it has to be subsurf. Like we got to figure out our subsurf scattering. It's just that it really reveals our intersecting geometry. I feel like that's the issue. But I think the translucency, which has this thing going on, I think is going to help us a lot. So if we either add or mix, don't know which, let's try to add. Whew. It's blinding. So I want this subtle. Before, after. Yeah, now it's starting to get the milk. We want some of the milk. Not all the milk. Some milk. Not all. What happens if I use this color here? Yeah. Some milk is necessary. Okay, before, let's just get a petal in here. Before, after. If you can't tell the difference, then neither can I. But it is a little different. Okay. Next thing I want to do that's going to really matter is going to be the bump mapping. Now again, there were these lines that mattered. So let's see if we can emulate that, kind of going radially outwards. So one of these, it's definitely not that one. That's, no. We'll make it ourselves. Gradient texture, we want the one that does a loop. That's radial, I believe. And let's use object coordinates. Yeah. Okay, so this wraps around. We can use that to make lines very simply by just multiplying this by a big number, like 100, and then since it goes from 0 to 100, I'm going to use that fraction. That's how you get those radial lines. One could argue that there's an easy way to do this with like ping pong. But I like fraction because it's this normalized 0 to 1. Sometimes play with the alpha. Interesting. I'll look at that in a second. Blah, blah, blah. I was saying something. I like that 0 to 1 because then I can shape it in a way that I find intuitive. So let's say it's all black, but then in the middle it's white. And in fact, it's going to be tighter. Actually, for something like this, let's just use a color ramp. So I'm basically doing the same thing, but with a different UI. So I'm just going to... So I'm just kind of creating a wave texture. And let's also make sure to... And we might just thin out our petals. I think that's like another thing that matters. But to get not perfect lines, you have to distort the input space. So you take your object coordinates, you add a contribution of noise based on normalized. So let's see. Yeah, so these make more intricate looking lines. And let's see what that gives us. So I'm also going to scale its contribution so it's not as in your face. So if I set this to bump, we're going to get bump mapping. And if I connect this to the normal, it is there. It is there. And I think if I turn it down like significantly, then I think it's better to have it than to not have it. I'm also going to turn on ease. So multiply by 0.2, multiplied by 0.1, multiplied by 0.01. I want it gone, 0.001. This is doing something, right? Or is this what the distance is for? 0.01. Or the strength. Okay. We'll do it like this. Yeah. Okay, so that's just to hit a detail. Okay. So that's something. Raphael, I think somebody recommended playing with the alpha. Ooh. I don't want them literally to be able to see through each other, but nearly. Somebody donated some money. What's it say? My dude, I need to relight a Gaussian splat scene in Blender. Is it possible? I'm 3D scanning the interior house using your plugin. So once you have a Gaussian splat, depending on how you're importing it in, Usually that information is stored in a point cloud, like that's how it's imported, and that point cloud has a color attribute. You can totally manipulate it like that. There's even an add-on that imports it as like transparent spheres, and that would interact with lighting. I do believe I have it in my Gaussian splatting tutorial. So look at that. I believe it covers it. And also, thank you for the cash. Okay, back to business. I think these petals are just too thick. Like they should be like stupidly thin. So let's see. We have our petals. How thin can we make them? So this is what like a single petal looks like, super thin. Okay. This is where I did my thinning. So this was before, this is after. It needs to be stupid thin, like 0.1. Oh yeah. Before, after, that's what's up. That was the issue. Okay, so this, 0.1, 0.1, 0.1. And then for that to happen, remember we have to rebake. And now we might need to adjust settings, but the fact that it's super thin I think will help. So how does the translucency behave? Yeah, a little differently, huh? A little differently. What about subsurf? Like, I know the solution is subsurf. I'm just not used to it. Ooh, okay, okay. 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 In that case, I can turn off this subsurf. Okay, okay. We're close. That was the money. That was the money. So before, after. Before, after. Okay. I'm feeling good about that. And we also have the index of refraction and things to play with. So if I set it to 1, can't even tell. The roughness? I honestly cannot tell. So I'm just going to keep it as is. Okay, there's the money. There's the money. And a lot of this can be, you know, color spaced or color graded to be correct. Is there no... I swear there was an RGB node or a color node. But I would like to get it as accurate as possible just in vanilla. Okay. Now, do I also want to add specular, more specular? I feel like it should have some anisotropy. I don't think I want transmission. I think that's overkill. And are these like so shiny that they have a coat? Maybe. Okay. Oh, by the way, I haven't played with this thickness. I don't know what it does. Anybody know how thickness works? Because it seems like that might be useful. Unless it's just to fix the lighting errors. So let's see. So this is our materials. This is our setting. Displacement. Emission sampling. Sampling. Yeah, I don't know what thickness does. If anybody knows, let me know. Yes, you can rewatch the stream. Until then, I will continue. So we have this. Can we mess with the hue? We can, but it seems like we shouldn't. It's just that they're so yellow. And I think part of that is lost. But really, it could just be the color space. So for example, if I turn this from AGX to, you ready? It's going to blind you. Chronos. Now it's very yellow. So I think we can recover this later. It just needs to be relative to each other, correct? Okay, so we have this. We got our bump, which should, I guess, also be here. And do I want it to be stronger? 0.001. Okay. I'm also going to throw on a bit of noise texture. Just a little. I know, it's a lot, but just a little. So I'm going to scale it up. I'm going to add some detail, and I'm going to bump up the roughness. Okay, just that micro detail, like that. And then I multiply to make it tiny. Like way tiny. So without, with might not come across in the stream, but it definitely adds something. But it should be so tiny. Okay. Next up, and again, I'm just going to assume I can correct that yellow. Next, let's go for the... And I could have the petals be different. It's fine. Wait a second. You can totally... Okay, I'll come back. I had an idea where it gets more transparent at the tips or whatever, but that's fine. Next, we have the... Let's go for the base. The base is probably pretty simple. So I'm just going to sample like this orange. Okay? Might be right. Might not be right. Make it a little brighter. A little less saturated. But you're not really going to see it much. So I'm going to make it max roughness. Next, we have the seeds. And that does matter. And it looks like they're green as you go inwards. So I'm going to start off like this, which seems to roughly be the correct color. And I need to make a gradient from middle outwards. So I'm just going to use the gradient texture to do that for me. Spherical. Forget it. I'll do it myself. Okay, so I'm making a nice gradient here. That does a color ramp. Peak trick here, boys. Hold E. Go like that. And now you got that nice color. Now, of course, that was too many. So I'm not actually going to do that. But it is a nice trick. So it starts off brown. And then inwards, it's this like sickly green. And that should be more prominent. The sickly greenness of it. It's kind of a very soft fall off. And then I feel like the brown is more like saturated and bright. Maybe less saturated. Oh, what did I do? Brighter. Okay, that's definitely something. I'm going to take the gradient and make it a bit bigger. And this is done with multiplication. So now you can see it's nice and soft. So let's do 0.5. Before, after. And we could take the seeds. So in geometry, we can use this random per... Never go through back facing. Okay. And random per island is going to let me vary the seeds. So let's do a mix color. It will be subtle. I'm going to multiply. So this is just going to make some seeds darker than others. And I'm going to put that in here. Actually, that's pretty good. I'll keep it like that. So that's a good thing. And I guess while we do that, let's go back to the petals and also have some variance a little using maybe using the color, although I do want the color to be consistent. Let's try it. So I'm going to have one of these be this, one of them be that. And then I'm randomizing per island, or maybe some of them are orange, but just barely. Just barely. Okay, next we have the pistil, which seems pretty similar, except once you get to the tip. So let's make it that brown that we had before. Maybe this is a good opportunity to look at one of the other images. Yeah, so it's pretty dark brown actually, which I think makes me also want to make the base much darker. Okay. And the tips, at least for some of them, are going to be yellow. Just the tips. Petal yellow color becomes brighter from bottom to top. Oh. Oh. That could help. Okay, let me quickly implement that in one more thing. So in our petal, so here's an example. I'm going to store for later use just an attribute. I'm going to call it gradient. And that's going to be its progress along the y-axis. So I'm getting that nice 0 to 1 gradient. That's going to go there. Great. Here's another one of those triples I was talking about. And that should now be in all of them, I believe. I've lost the sauce. So we have a petal, and now this petal also has the store. Okay. And the second thing I wanted to do while we're there is the pistils. I also want to have the gradient from bottom to top. And because it's a curve, it's kind of easier to do that. So I'm going to store named attribute. This can also be the gradient, but this one is just going to be dependent on where it is along the curve, the spline parameter. Okay. To do all that, you got to bake. You look at it there. And let's see that information. So let's go to the petal. And I think it not only... Yeah, it kind of gets brighter, you're right. So now let's see our gradient, which is an attribute, not the actual gradient. Okay, so now we have that information. And maybe what we can do is we can take this and throw it through a hue saturation value. Okay, so we have this, and they get brighter. So right now I have that inverted, but they get brighter. I want to have very exact control of this. Okay, so before and after, let's see. So before and after, let's make that way more visible. Well, it's there. We can also like do things like affect the saturation, but it is there. Okay. And then the pistol thing that I was doing, let's get back to that. That also has a gradient texture, or a gradient parameter. So you can see it's black on the bottom and white on the top. And I can use that to mix between two colors where I said I wanted some of those yellow tips. So let's get that nice yellow. And that is going to be based on the spline parameter, which right now is inverted. Okay, so you can see it's, oh no, is it inverted? No, that is how we want it. So like that, like this, yeah, like that. And you can see it's only at the very, very tip that it does that. And it seems like it is only the ones on the interior for some reason. So maybe we can randomize which ones get this, again, using the random thing. So this is one. That's another. Make it brown. Whoops. Make it brown. Random per island. And then this should have a cutoff. Okay, so when this is 1, they all have it. When it's 0, none of them have it. When it's 0.2, 20% of them have it. I think that's good. Better than what we had before. Are the petals reflective? I think they were. Yeah, like you see that highlight right there. It's a bit more orange at the darker parts. Maybe. Maybe. And if that is the case, that's just a matter of saturation or something. Or a matter of hue. That's funny. Yeah, it's kind of a matter of saturation and hue. Well, we can see what that looks like. So I'm going to mix colors with this. We have that map over here. That lets us mix that. So now we have before and, oh wait. Yeah, we have before and after. Am I crazy? Oh no, we have before and we have after. But that is inverted, so white goes here. Yes, that is inverted. Okay, there we go. So before and after, let's just see if that adds anything nice. Hmm? So before and after. Ooh. I don't mind that. I think it's a little intense, but I don't mind that. So just to see, before and after. Okay, okay, okay. Now remember, a lot of this is lighting dependent. I just do one number, it's a different flower. Somewhat. But I think, yeah, I think now let's try to go into compositing and just see if we can like push this. I think it's time to push it to the limit, if you will. So we are in cycles. Let's do 300 samples with a denoise at that resolution. So good, so good. Okay. Well, there goes our reference. Let's bring it back. Okay, render. Oh, thank God it's not like yesterday. It's actually working. Oh, wait. I forgot something. What does this look like, by the way? That's interesting. I forgot my render passes. So I'm going to do normal. I'm going to do position. I'm going to do ambient occlusion. I might do color. And I might do material so I can isolate them. And then maybe for the camera, I can add just a little dopf. Because sunflowers are big, but they're also kind of tiny, you know? So we have that. I always like to push it to 0.1 just to see. Okay, so that's correct. Set it to 1. Still much. Set it to 1.8. Okay. Before, after. Might add realism. Who knows? Render. And we're almost at 3 hours, but I think we're almost, we're almost through. And it's really interesting to maybe see the seeds come out. Now, I know this isn't Bouquet, but, it's unique. Like, who else is simulating seeds in a way that they follow the fib? Come on. Come on. Scared of sunflowers. They could just eat you like a Venus flytrap. Let me reset the goal. Oh, wait, I forgot I was supposed to dab. There you go. I dab again. Okay, come on. Give me the money. Give it to me. The money's mine. Give me the money. Okay, good. So now, I don't want it. So now we do compositing. This is what we have initially. And it might be helpful to just have this over like a neutral gray or something to compare. Let's have an image. And I can also lock that in. Well, no, I don't want to lock it in. Okay, so first order of business. It's not yellow enough. It's kind of this other thing. So I'm gonna, many ways I can handle this. I am going to start by color correcting the petals, which is why I have a crypto mat. So these are our petals. That I can isolate. So now I can do whatever I want, and it will only be to the petals. Okay, so let's figure out what numbers need to be manipulated here. Before, after, we're getting closer. I think they are too reflective. I think somebody said that a while ago. They are too reflective. So let's quickly take care of that. This time I'll do a lower sample render, so it's actually faster. They are too reflective, which was a consequence of the specular being too high. So no reflection, some reflection. So maybe 0.25, and then it's the clear coat as well. That's to blame. So maybe 0.2. And the subsurf was looking kind of sort of intense, see? Bring that down. And then finally, the bump mapping was not to my liking. What am I looking for? Why can I not see? Ah, because of that. So wait, I had this gradient texture. I multiplied by 1,000 and ran a fraction. That creates the lines. I want it to be not as many and maybe have a bit more contribution. Yeah, so now they're actually doing something. Yeah, let's make that a bit rougher. And I think, why is it? It must be the sky texture. There's no other way. Yeah, it just kind of looks too slippery. Which I can minimize by having a little less sunlight. Yeah, it's so shiny. Why so shiny? Okay. Like this, like that, like that. Okay. Let's compare. Okay, before, after. Okay, that's a major improvement. We're not there yet, but that's a major improvement. Okay, so they just need to be that color. Still kind of looks like Play-Doh. How did they make it look so thin? I mean, by taking a photo, I know it's a real thing, but oh, maybe it's the IOR. I don't even know. I think it's like a little greener than what I've been doing. Ooh, backlight. I will try it. Oh, okay. Without, with. Great idea. Great idea. I want it just a little greener. Ooh, that helped. That definitely helped. Yeah. Okay, let's try that again. Subsurf on the principled BSDF. Put all radius settings to 1. I don't think it's even enabled, is it? No, there isn't even subsurf. But if you mean this one, doesn't really make much of a difference. Okay, back to compose. Okay, we're definitely closer than we were. Okay, and we can also accentuate the details by using a sharpen that only shows up once again on the petals. Okay. Next up, I believe the colors of the base could be better. So I am going to select the base. Okay, there we go. That's the base. And that also needs its own hue saturation. So now if I modify this, yeah, it will only modify the center. So it needs to be brighter and more like orange. So before, after, it's definitely closer. Okay, so before, after. Okay. So this is where we started off. This is where we are now. One trick I always like to do is because I render out the ambient occlusion, which has all this like nice detail that gives it that three-dimensionality, I multiply. I multiply. So before, after, let's actually do it. What happens if we do it here? Okay, so before, after, it just adds some like depth that I feel like is needed, even if it's a little. Next, we have our diffuse color. We have our position. Okay, and we have our normal. I think I want to use the normal. So I'm going to use a normal node. Is there not a, there was a normal node. And I'm going to dot product. So now what this will let me do is as I rotate this, it will let me accentuate certain parts like these lines and stuff like that, which I want to maybe brighten or something. We'll figure it out. So once again, yet another hue saturation value. It's just the easiest way for me to edit. And what do we got? So if I was to do that, I could do that. If I was to do that, now there'd be more highlights, right, as you can see. Could definitely do something. I think brightening helps. And then, like I said, I can always manipulate this as I go. And I think I only want this to affect, I know we're messy, but I want this to only affect the petals, which is this one. So now we've isolated that. And that just lets me get more detail. Okay. Some other tricks are, first of all, now that we've done that, our background just might not fit the situation. Like, just that already changes the mood, which just shows how important it is. Okay, other things. I'm going to add just a light amount of glare. A light amount of glare. So I need to see what parts are the brightest. Bring down the strength. Before, after. I mean, like, I guess sun's pretty good. Or glare of the sun when it is a sunflower and you're trying to illustrate that. Okay. Now, I like to play with the gam, which, let me turn on GPU. Just gives it a vibe. No, that's fine. There's some new nodes or node groups like sensor noise that just add, you know, sensor noise. It's always good to have a bit of grain on your render. Yeah, you're right. I think you're right. I think maybe so somebody's saying one of the bottlenecks is like the modeling of the petals. They just need more detail. I could believe that. We could do that for free and still get all our compositing. So for the petals, I'm just going to go into one of these and so this one's the curvature. Maybe I'll bump that up a little. This one is the curve, which I think also could use just a little. Okay. Next, we have, oh, cursed. That's interesting. I forgot how much control we have. Yeah, they were too round. And like that. And then where did we make that wave texture? Okay. And now finally, I think I'm just going to distort our coordinates for these lines so they're not as perfect. Oh, wrong place. There we go. So all I'm trying to do right now is just add some distortion to the position coordinates. So without, or, without, with, okay. I mean, the petals are like, they're thin. They're about as thin as you can get. But maybe they just don't have as much curvature as something. Like maybe that's why they feel like too three-dimensional or something. So maybe that's what you meant by like 2 3-dimensional. Well, we can always just see what this looks like. So this is what we had before, and let's rebake. Maybe the blooming is still a bit much. A little less bloom. And it could also be, by the way, that the angle is just like unnatural, which would make sense. Like if we want to replicate the image, it's more like something like this. And sorry that I'm not talking, I'm just in experimentation mode. I think we're definitely like way closer than we were in the beginning. I think that's fair to say. So does all this help or hurt? I guess like one thing is all of this, like basically everything except for the petals, which I can isolate just like so, is like more orange almost. So I am going to, what is this already selected on? Oh, that's fine. So I'm going to also pick the pistils, and I'm also going to pick the seeds. Still didn't get the pistil. Okay, all of that seems to just be a different color in the image. So I'm going to do all that, and then another hue saturation. And maybe we'll just do a color mix, we'll see. But for this, it's just the wrong color. That's already looking more vibrant, I think is fair to say. But how do I get that nice orange? Maybe I mix the color orange. Uh-huh. And then it's one of these blending modes. Mm. Okay, so this is without that modification, and this is with, which to me says great. But now the green of the seeds, a little too green, which is an easy fix because I go into the seeds, I go into the gradient, I take that gradient, I bring it in, and then I make it a bit more red. So a little less green. Let's see what that looks like. Vivacious. Thank you, everybody, for the praise of this render. Okay. Okay. And then let's see about the overall kind of color. We can also do stuff like there's like white balance now, apparently, or there has been for a bit. So this could be on a cold day. This could be on a warm day. I imagine we probably want a warm day. And then another thing I'm curious about is I forget, what did the background look like? I mean, it's a pretty nice contrasting color. Because the camera's so far away, because it's orthographic, the depth of field plays weird. Okay, I mean this feels like it's a sunflower, and let's again help with this sad background. Could even add a gradient if I wanted to. So it should be brighter to match the mood. Yeah, that already makes it feel more like alive. And you know, there is an argument, sorry, to be made for a stem. But this is starting to look much more stylized, sure, but also vibrant. Maybe if I make this a little less than yellow, like orange, it will make the sunflower look so much more yellow. Somebody's saying purple. It is. But I do think, I do want to go like, it's bright. So I'm going to do that. I'm going to throw on my vignette, little vignette. Never too much vignette. Always subtle. Before, after. Just subtle. And maybe some lens distortion, but not chromatic aberration, just some distortion. Three and a half hours. I'm probably going to wrap up soon, by the way, so I can work on stuff. Okay. And now, like, the last thing that's feeling weird is just, like, the camera angle and maybe the lack of a stem. And maybe the fact that it's in perspective. Let's go back with what we had and just see what it would be like to add just a super simple stem. Nothing crazy. Look at how big the IDs are because of the thing. Okay, so just a basic stem, like a cylinder. So we have all that. Great. And now I'm going to do maybe just like a thickened curved line. Curve to mesh. You can start way lower. Even lower. And then it can go less high. Yeah, why not? And this can get a material that I'm going to call stem. And I'll add a bit of something to it in a second. Stem, just to start off with, I'm going to make it green. Well, I'll make it gray to start. And then let's give this some form. So resample this. Just a little bit of distortion. Something like that, but like softer. 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 Okay, there you go. I know like stems have these tiny, I don't know if they're like literally hairs, but they do kind of look like hairs. I think the stem material maybe this one is as simple as a subsurf. So it's going to be green, greenish yellow, not that much. Okay. That's kind of something. It's surprising, like the stem is so easy to make look good if you consider this good. I do not go live every day at the same time. Every day in Nodevember, or many days, I might like pack multiple in the same day, but not every day, and definitely not at the same time. Okay. And then maybe one more distort. That's a crispy looking stem. Ooh, we have a decision to make. if we make the stem dark, it would really bring out the vibrance of the thing. It really would. And by the way, I understand this makes like no sense, but from the direction of the camera, makes quite a bit of sense. And I think, just those little hairs. No one will notice. Well, they will notice, but subliminally. Let's turn off the depth of field. Ooh, I might try like zooming out, because that's actually a great angle. Okay. So just little hairs. That can be done by distribute, points, on faces. These are going to be our hairs. We are going to instance a curved line, very tiny. We are going to run a curve to mesh to make it kind of like cylindrical. Make those super thin. And then to orient them, you do that. So now you have these super tiny hairs. And I'm just going to give it the same stem, because it sounds like a lot of work to do anything else. So let's see. It's looking good. Even thinner. And then somewhat taller. And then with some randomness. Okay, almost done, almost done. I do think I changed my mind and that I do want to do this curve to mesh after, so that I can do just a bit of a distortion, which means I need to resample. So I'm basically making a curve with some detail, such that before I solidify it, in a sense, I distort it, where the strength is going to be based on the spline parameter. That way it can stay attached. And that should be realized. Okay, so you can see they're attached. And I make it very micro detail. Just little hairs. Little hairs never hurt nobody. Okay. Moment of truth. Does it look better? It looks better. It looks better. But they should be so thin. Like however thin you think they should be, more than that. And maybe there can be more of them. So it's nice and furry, and it captures the light, and everybody's happy. Have I ever been to a sunflower field? No. Does it show? Okay. And I'm almost tempted to give the petals the same treatment. Like, I know that doesn't make sense. All I'm saying is I'm tempted. And I'm also tempted to let my PC crash, apparently. I mean, doesn't make any sense, but it is nice. Okay, let's throw it through the render again and see what we get this time. So as a reminder, this is where we started off. And we made a lot of modifications, which we'll see in a moment. So this is where we started off, and this is where we're at. Background's a little strong. But other than that, we are vibing. It's vibes, and it's always been vibes. It's really hard finding the right color. Okay, so let's see. It's almost like they should be having so little shadow. That's also without the depth of field. Okay, final thing before I'm done, and then I'm going to wrap up the stream. Just as a sanity check, I want to make sure, so I did all this work. I just want to see if like a simple change of the orientation of the sky makes a difference. So that already made it look warmer, for example. So I might play with that by myself. There's also the angle of the sun, which makes the petals look lighter. I'll play again with that later. And the altitude. Yeah, all of these things matter and might increase the quality. Okay. So I am going to wrap it up here. So you saw I used a lot of nodes that, especially normalized field, that doesn't come with vanilla Blender, and that can be found at cgmatter.com. There are free nodes. So if you go there right now, you can get like 40, 50 free nodes that I find useful. I like the distort one all the time. I would also recommend, so you literally just type in cgmatter.com. I'd also recommend reading the blog, which is faint. And then, if you're so inclined, join the member-only site where I am uploading the Nodevember projects, including this roasted marshmallow, which I think so far is my favorite. So check that out. It seems like every live stream a few people join, which is nice. And yeah. Yeah, okay. Thank you everybody for watching, and I will wrap up the render and post it on Twitter later. And as per tradition, I will answer one question. Just one. Will it be you? I'm going to wait 30 seconds, and I'm going to pick the most interesting question. Okay, they're coming in. Well, when I say they, I'm saying one is coming in. Will there be variety? Will I answer the one question? If you're sitting there, there's like 70 of you. It could be you. Okay, I'm going to wait 10 more seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, we got questions. I'm going to go with the second question, at least on this list, that says, Concerning 3D, when or how does one stop feeling like an amateur? I stopped feeling like an amateur once somebody reached out to me for freelance work. So somebody watched what I do, and they're like, I'm going to personally contact them with a job that I believe this person can do. And it did take getting paid, or at least being selected, to stop feeling like an amateur. It wasn't really like, did I have skills or not? It was like, did somebody want what I make? So that is my answer to that. Very good question. So now I'm going to wrap up the stream. Thank you everybody for watching. Again, that is going to be www.cgmatter.com. I'll see you on here tomorrow for day 5.